Well, good morning, students. What we're going to do today is do an SAT question. This has to do with a quadratic. This question says here that the function g of z is p z squared plus qz plus r, and it has zeros at z equals 1 and z equals 7. Suppose p is an integer greater than 1. And which of the following could be the value of p plus q? All right, so when we go up and look at the function, one thing that could throw you off is all of the letters here and not knowing which one is the true variable, right? The independent variable. It's z, right? So z is like our x. So that means that the p, the q, and the r are going to be our missing coefficients, the numbers that are supposed to be there, and we're supposed to figure out based on the zeros being at 1 and 7, the x-intercepts being here, what are the values of p and q so we could add them together. Well, what we're going to do is we recognize it is a quadratic, and therefore g of z can be constructed by looking at these zeros, right? Because if the zero is at 1, that means there has to be a factor in the factored form of the quadratic of z minus 1, and a factored form, in factored form, there'd have to be a factor of z minus 7, which would then create that that 0 over here at 7. Now, one of the things that we know about standard form, which is what they're giving us the equation in with these p, q, and r coefficients, and the factored form, is that this coefficient is going to be present in the other forms of the quadratic. Remember, 3 forms in any quadratic. You have the standard form, which is what they presented us the function g in. We've, though, constructed an equivalent one in factored form, and there's a third one called the vertex form, which we're not going to be looking at here in this problem. But what I'm going to do, given that we had those zeros, I'm going to go ahead and convert from this factored form, in the factored form into standard form. So I'm going to go ahead and multiply z minus 1 times z minus 7. And that would look like this. This would be, I'll leave the p out here for now, but that's going to be z squared minus 7z minus 1z will combine to be negative 8z. And then minus 1 times minus 7 is a positive 7. All right, now what we could do is we could distribute that p all the way through, right? That may be our next best option here. And that's what it would have to look like, because remember, it's saying that p is an integer that's greater than 1. So p could be 2, 3, etc. is what that has. It has to be an integer and has to be greater than 1. All right, so then what could be the values of p plus q? Well, at this point, what we could do is we could say, in this case, that the p is this right here, and this is the q, right? So negative 8p ends up being the q that would match with the standard form of the equation. So what I'm going to do then is they're saying that what could be p plus q. So I'm going to say p plus q would be equal to p plus a negative 8p, which would then be negative 7p. Now, if p is an integer that's greater than 1, it could be 2, 3, 4, or 5, which means the only possible values for p plus q, which is negative 7p, would have to be negative 14, negative 21, negative 28, all the multiples of negative 7. And you can see that the only one in that list that's going to work is going to be the negative 14. All right, so that is an example that is pretty common on the SAT, where you're working with a quadratic and they start you in standard form, and then you have to construct one of the other forms based on information given. In this case, when they give me zeros, I'm going to construct the equation in its factored form. If they had given me maybe the vertex, I could have gone down that route and made the equivalent g of z, but in its vertex form. Okay, I hope that was helpful, and hope you all have a great day. I will be back tomorrow. I'm going to do another SAT problem of the day. Take care, everybody.